Now, second derivative. Okay, look, again, this is a quotient rule, and don't forget there's a minus outside. You have to keep it alive. Okay, so don't forget the signs basically. Second derivative is a bit complicated, so do go over this file which I will upload for you so that you can see the steps. When I square it, it becomes fourth power. When I go to the numerator, derivative of the top, denominator as it is minus, numerator as it is, derivative of the denominator, that is chain rule. 2 comes down, this quantity power 1, and then go inside, take its derivative, that is a 2x there. Alright, and when you simplify, you get something going on, right? And now division distributes, so that simplifies nicely. Okay, there are ways to simplify and ways to simplify. Make sure you get the same denominator, common denominator. This is degree 2, this is degree 3. So to get a degree 3 here, I need to multiply by one more power. Okay, that's where this came from. And then simplify. And this is the final answer I get. Okay. All right. That's my second derivative. Inflection points. Inflection points are points on the curve whose concavity changes. Well, that is concave up to concave down and so on. So you want second derivative to be 0 or second derivative to not exist. Well, when does second derivative not exist? When the denominator is 0. But we saw this just a short while ago. X squared minus 4 equals 0 means x equals plus or minus 2, which are not in our domain. So they don't contribute to inflection points. The only way I get inflection points is by setting second derivative equals 0. Potentially, okay, there is no guarantee. One way to find inflection points is set this to 0 and hope concavity changes from left to right. Anyhow, take this equals 0, cross multiply, divide by 40, I get 3x squared plus 4 is 0. Take the 4 to the other side, divide by 3. X squared is a negative number. If square is a negative number, my x is imaginary. In other words, I have no chance of solving this in the real world. Okay? So, I have f prime to be undefined for 2 and negative 2, which are not in the domain, and they are the only cut points. Now, so I have 3 intervals, 1, 2, 3. I chose a test point from each interval. I plugged it in the expression for f double prime, and I am worried only about the sign. I don't care about the final value, only the sign. And I substituted and I received these signs. When f double prime is positive, f is concave up. When f double prime is negative, f is concave down. Okay, so that's what tells me I'm concave up here, concave down here, concave up here. And there is no inflection point anywhere. These numbers are not in my domain. Okay, so there is no inflection point here. Keep that in mind. Symmetry. Is my function an even function? That is, f of negative x is fx. Well, check. If I substitute negative x for here, they get squared and I get the same function back. Yes, indeed. F is an even function. Okay. So, here is the graph. I'm increasing. This is my horizontal asymptote. These are my vertical asymptotes. I'm increasing here, going to positive infinity, concave up. I'm increasing here, concave down, decreasing here, concave down, decreasing here, concave down, and asymptotically I tend to y equals 5 on both sides. All right. So this is our graph. This is, by the way, a local maximum. There is no other maximum or minimum. Okay. 0, 0 is the only place where you get a local maximum. The actual graph, look at that. That's our graph by hand drawing, and this is the computer generated graph. Okay. So with all this information, I have substituted here. Keep in mind, infinity is denoted in this problem with an INF, union by U. Okay. None. DNE is not the, it did not accept. It accepted none. I hope I don't have anything else to say. Okay. Something is incorrect. Oh, that I did not fix it. Where is the second derivative? There is my second derivative. So, that's my second derivative. X squared plus, 3x squared plus 4. Okay. All right, everything is good. Until next problem then.